All right, so graphing secant and cosecant functions, it says the cosecant and secant functions are reciprocal functions. We can use a concept as an aid in graphing. Each reciprocal function behaves as a skeleton for the graph in question. So, remember secant's a reciprocal of what? Cosine, and cosecant's a reciprocal of sine. And cosine and sine each had a period of what? 2 pi. And so the reciprocals are going to have the same exact period, okay? So for secant and cosecant, both of them are going to have a period that is 2 pi. All right, so for the first one here, y equals cosecant of x. You just told me it's the reciprocal of what again? Sine. And so remember we had talked the other day and we said we had a parent table for sine of x, didn't we? So if we start at 0 and we go to 2 pi, we used our x values that were our quadrantal angles. And remind me, where did sine start at? Does it start at the top, the bottom, or in the middle? In the middle. And then does it go up or down? Good. All right. Now, if cosecant is the reciprocal of sine, we can use our sine table still, and we're going to plot those points, just don't connect them, okay? So let's go ahead and plot those points. And the reason we do that is because there's very little that's going to change between sine and if I actually made a parent table for cosecant. And I'll write it down in a minute what one could be. But remember, if you're going to take calculus next year, you have to kind of memorize all this stuff. And so I'm trying to show you, I'm going to show you a way to do it without having to memorize an extra table. Now, we're saying that y is going to be the reciprocal of the sine, correct? So let's just take the reciprocal of our y's. So what's the reciprocal of 0? Well, 0 is like 0 over 1. And so if I take the reciprocal of that, I'd get 1 over 0, which is undefined. What's the reciprocal of 1? Of 0? Undefined. What about negative 1? Still negative 1. And 0? So the only difference really between sine and cosecant is my zeros became undefined. Now how do we graph undefined? Yeah, the vertical asymptotes, right? So wherever we had our zeros, or look at look at the points that we plotted, our zeros are always going to be our midline. Well, when you see this, you can see that this is a top point, right? This is a bottom point. So those that are in between it have to be in the middle there, aren't they? Those are your asymptotes. So right here where x is 0, there's an asymptote. There's another point there in the middle at pi, so that's another vertical asymptote. And then there's another one here at 2 pi, so it's also a vertical asymptote. Now remember, when we graphed sine, you don't have to do this, I'm just going to kind of do it dashed here. It looked like this. But now we're doing the reciprocal. And what does a reciprocal mean to do like with a fraction? Flip it, right? So do you see those little kind of parabolas we have going on like right here and right here? We're literally going to flip them because it's a reciprocal. So where I have that positive 1, I'm going to have a little parabola that's going up that's shaped by those asymptotes. And at the negative 1, the bottom points, you'll have them going down, also just shaped by the asymptotes. And so that right there is one full period of my cosecant function. Okay? So you do it just like you do sine or cosine, except that midline, those points become your asymptotes. Top points are little parabolas going up. Bottom points are little parabolas going down. Now, of course, because we have asymptotes and stuff, our domain and range and all that will change. So for cosecant, what is its domain? Well, let's do it like we did the tangent and the cotangent. Let's talk about what it can't be. So our domain is that our angle theta cannot equal what? 0. And how often is that going to happen? Every pi, right? So we put 0 plus pi k, which 0 plus pi k is just pi k, isn't it? So we could abbreviate that. And because we use k, we have to use that notation. K is an element of the integers. Now remember, we could have used more than just, we could have used anything other than 0. We could have, looking up there, we saw it wasn't equal to it pi. It also wasn't equal to it 2 pi, okay? Could have used any of those. What's my range?
Negative infinity to negative 1, and then 1 to positive infinity.
There you go. She's right. So negative infinity up to negative 1. That's included because it's a closed circle. And then we have a gap there, so we jump up towards positive 1 that's included, and it keeps going up to positive infinity. And then where are your asymptotes? Right. They're the same thing as what the domain cannot be. So therefore, they're at x equals that pi k, where k is an element of the integers. Now, if you just really want a cosecant table, we just wrote it over there, but I'll write it again. Yeah, we said 0 became undefined, 1 stayed the same, 0 is undefined, negative 1 was the same, and 0 was undefined, right? If you just really want one. But you don't need it because you already know sine of x, and this is just the reflection of it. So the midlines become asymptotes, not reflection, sorry, reciprocal. Midlines become asymptotes, top points are parabolas going up, bottom points are parabolas going down. You had a question? All right, questions on that? So let's look at secant. You told me secant's a reciprocal of what? Cosine. And so I'm going to use my cosine parent table to help me graph this. So remember, it has the same x values as sine. It's only tangent and cotangent that are different, right? But where does cosine start at? Is it the top, the bottom, or the middle? Top. If it's at the top, it has to go down, and then it's going to come back up. So just like what I did before, I'm going to go ahead and plot those points, but I'm thinking I'm doing this secant, so I'm not going to graph it yet. All right, so once you get your points on there, remember your middle points become what?
Asymptotes.
That's where the asymptotes are. So make sure you see your top points. You got more than one this time. And your bottom point, which means These other ones are your vertical asymptotes, or they're where your vertical asymptotes will be. All right, what are we going to do at the, let's do the bottom point first this time. The bottom points become little parabolas going which direction? It's a bottom point, they got to go down. Am I going too fast? And then top points are going to go up. Thank you. Now we just did the part that went up towards that asymptote. You can continue the pattern, and let's do that on this one. All right, so I can't go to the right anymore, but I can go to the left. And so I can see that every two lines right here, there's an asymptote, correct? So I know that right here, there's going to be another asymptote. And I'm going to go ahead and just put my asymptotes in here. And then looking from the far right, they're going towards the left. I have a top point, an asymptote, a bottom point, an asymptote, a top point. So an asymptote, a bottom point, an asymptote, a top point. And then just finish filling this in. For secant and cosecant, guys, it takes a little parabola going up and down for it to be a full period, okay? Now, when we first drew this, we had a full period because we had a full one going down and we had two halves that were going up. Two halves make a whole. All right? But I know some of y'all don't like it just being a half. You want to extend it on, and if that's the case, then you can. So tell me about its domain. Again, since it's got asymptotes, let's talk about where it can't be. So theta cannot be what?
1/2 pi.
Okay, so pi over 2 is one of our asymptotes, correct? And it's going to happen every how far do we have an asymptote?
Pi.
Every pi, so plus pi k. K is an element of the integers. What is your range?
Same thing as the last one?
Yeah, same thing as the last one. So from, negative infinity up to -1 included, union, then it jumped up to +1 included, and it goes up to positive infinity. And just like the last one, our asymptotes are going to be x equals, where are asymptotes at?
Same place as what's it called?
Same place the domain cannot be. So the pi over 2 plus pi k. Now, if you just really got to have a secant table. For y'all who know you're taking calculus, I don't want you to depend on the secant table, okay? Double check yourself with it if you want to, but try not to depend on it because I don't want you to have to memorize something else unless you're just really good at memorizing tables. So just like we did with the cosecant, the ones and the -1 stay the same. The zeros just become undefined. So 1, then it was a 0, so that's undefined. -1 at 0, so it's undefined, and back up at +1.
So that, what's the difference between that table and the cosine of x table? I'm confused.
I took the reciprocal of the y values. That's the only difference.
So that's just undefined instead of 0, but they're the same thing?
They're the same thing because they're
But
reciprocals.
there's asymptotes here. There's
Because of the undefined.
this kind.
All right, questions on that? But for our examples, when I work these, I'm going to work it like it's sine and cosine, and then I'm just going to do the reciprocals. So I'm not actually going to use those cosecant and secant tables. All right, so let's look at example 5. says use transformations, graph each function, its reciprocal, state the period, and show all asymptotes. All right, cosecant is a reciprocal of sine. And so I'm going to look above at my sine table that I wrote down, okay? I'm not going to rewrite it again because I'm kind of squished for room. But we have it written down up above. All right, so for this one, what am I going to do to, is there anything that's going to affect my x values? Yeah. It says x divided by 2. So what are we going to do to our x's? Good, because remember x always does the opposite, right? All right, and nothing else in there with x. So is there anything that's going to affect my y values? Well, it says 2 times cosecant, doesn't it? So 2 times, so we're going to multiply it by 2 as well.
Wouldn't the period just be 2 pi?
No, because we have a b value. We'll talk about that in a minute, though, okay? All right, so let's take all of those x's, and we're going to multiply them by 2. So my first x was a 0 times 2, which is... And then my next x was pi over 2 times 2, which is pi. My next one was pi times 2, which is... All right, and do you see your pattern there? So if you see it, keep going. Otherwise, keep working out like what we're doing. So we have 0, 1 pi, 2 pi. What's next? And what's last? Yeah. So if I work the other ones out, I would get the same answers, okay? Now for the y's, we're just going to multiply them by 2. So my first y was a 0. What's 0 times 2? And then 1 times 2? 0 times 2? Negative 1 times 2? And 0 times 2.
So we're not doing this one based off the undefined?
I'm not. I'm going to use my sine and cosine tables because I don't want to have to memorize another one. Okay? I'm trying to do this for y'all who are going to take calculus. But otherwise, you could do it off of the undefined. It's just like last time. The undefined is going to stay undefined no matter what you do. So when I graph these, I'm just going to graph the points, remember? So 0, 0, pi is at 2, 2 pi is at 0, 3 pi is at negative 2, and 4 pi is at 0. Now, the hardest part on these when you do this, though, is you got to remember you're using a reciprocal function, okay? Don't get all excited. I got my points. Let me connect them and call it done. Okay? The reciprocal functions, remember, your middle points, the line that has those middle points on it, those middle points become vertical asymptotes. Top points would be graphed to parabolas going up. Bottom points are little parabolas going down. All right, well, we already said what it was the reciprocal of. So when it says the reciprocal, we're just going to write y equals, it was 2 cosecant, so we're just going to put 2 sine of the x over 2. And then for its period, we have 2 ways that we can do it. Since we've got it graphed already, we can look and see how far apart those outside 2 things are, right? Or in my table, how far it is from the top x to the bottom x. Or we can use our formula. Now remember, they have the same period as the reciprocal. So we said the normal period is 2 pi, but of course we changed this one. But your formula for your period is still going to be the same as it was for sine, which is 2 pi over b. So if you use the fact that it's 2 pi over b, remember that x divided by 2 is the same exact thing as saying, 0.5 or 1/2 x. Okay? So your b value is a 1/2. Or you can look at your graph and you can say, oh, well, it goes from 0 to 4 pi, which is how far? 4 pi, isn't it? Or take your, your period is equal to 2 pi over, and we said b was 1/2. So we're going to multiply by the little 2 on bottom to get rid of it. And so we get 4 pi over 1, which is just 4 pi that way. Okay? All right, for b, this is graph y equals -2 secant of 3x. So what's the reciprocal of that? Y equals -2 cosine of 3x. And I could go ahead and find its period, because we know the period is equal to 2 pi over b. What's the b on this problem? 3. It's the number in front of the x. And so we can't simplify that, so our period is just going to be 2 pi over 3. And we'll see that when we actually graph it as well. All right, so using our cosine table, is there anything that's going to affect my x's?
3.
Yeah, that 3. So say it again.
Divide by 3.
Yeah, we're going to divide by 3, or that's the same as multiplying by 1 over 3. Good. Is there anything that's going to affect my y's?
So -2.
Yeah, so we're going to multiply by that -2. This says -2 times. All right, so using my cosine table that we wrote above, we're going to take all of our x's and either divide them by 3 or multiply by 1/3. So what is 0 times 1/3?
0.
Okay, what is pi over 2
Pi over 1.
times 1/3? Pi over what?
6.
Okay. What's pi times 1/3?
Pi over 3.
What's 3 pi over 2 times 1/3?
Pi over 2.
Everybody okay with these? That one you'd have got 3 pi over 6 and just reduced it, right? And got pi over 2. And then my last x was 2 pi. I'll multiply that times 1/3 and we get
2 pi over 3.
all right, so if I was going to use my table to look at my, so look for my period, I can see it goes from 0 to 2 pi over 3, which is 2 pi over 3. And let's keep going. Whoops, let me do that. Okay, so my y values, we're going to take all those y's and we're going to multiply them by -2. Now looking at my cosine table, started the first y value was a 1. What's 1 times -2? All right, then 0 times -2? -1 times -2? 0 times -2? And 1 times -2. I can graph those points. Oh, where's pi over 6? Okay, well, if you're unsure, we can definitely see where the pi over 3, 2 pi over 3 is, can't we? And so we know pi over 3 is halfway between them, so pi over 3 has to be this mark here. And then pi over 6 is halfway between that and 0. And pi over 2 is halfway between the pi over 3 and the 2 pi over 3. Okay, remember, use the fact you know that they're equal distance to help you find them if you need. Now don't connect the points yet, because remember we're doing secant. We're doing a reciprocal. So with the reciprocal, find your middle points. Those become your asymptotes. Top points are little parabolas going up, and bottom points are going to be little parabolas coming down. And that right there is actually a full period because you got one parabola going up and you have two halves that are going down. Now the only difference between this, and remember the sine and cosine ones, is I wouldn't have to worry about once I plotted my points for sine and cosine, we would have just connected them. Secant and cosecant, we have to go a step further. Okay, we have to put in those vertical asymptotes and then do our little parabolas. Questions on those two? All right then, and the last part here is that phase shift and standard form equations. So there's really two different ways that we can do these. All right, but I mean, if we already know one way, why? I don't feel like we should have to stress out trying to figure out something different. So, what's that? Okay, so we're just going to go through and graph these. So don't worry about where it's telling you to find the C over B and to add the period and all of that, okay? Don't worry about this part. We just want to graph this. So, cosecant's a reciprocal of sine. So for remember my sine parent table here. And sine starts where? In the middle, and it goes which way, up or down? Okay. Is there anything that's going to affect my x's?
Negative pi over 2.
Yeah, the minus pi over 2. So what are we going to do to our x's?
Add.
We're going to add pi over 2. Good. Is there anything that's going to affect my y's?
2.
What are we going to do then with it? Say it again?
Multiply.
Yeah, because it's 2 times that cosecant, so we're going to multiply by 2. All right, so for my x's, my first x is a 0. I'm going to add pi over 2. What does that give me? Pi over 2. My next x was a pi over 2, and I'm going to add a pi over 2, which gives me 2 pi over, keep the common denominator, which is a 2, which reduces to pi. All right, then we got our next x was pi plus pi over 2. So if nothing else, you really should find a common denominator, right? So this is the same as saying 2 pi over 2 plus 1 pi over 2. So we do get 3 pi over 2. But I told you in your calculator, you could put it in without the pi's. So it was a 1 pi, so we'd do 1 plus 1 pi over 2, so take the pi out, so plus 1/2. It's going to tell you 1.5. We like it as a fraction, so just hit your math in or enter, right? And it tells you 3/2. So you know that it's going to be 3 pi over 2. And then we have what? 3 pi over 2 plus pi over 2? That's what? 4 pi over 2, which reduces to? And then our last one there. Oops, I'm out of room. Let's go across on the bottom there. So we had 2 pi plus pi over 2. So if you're getting a common denominator, it's what? 4 pi over 2 plus a pi over 2, which is, good, 5 pi over 2.
You basically just took away the 0 and just bumped up the list a little bit.
Yeah, because we literally shifted to the right pi over 2, didn't we? That's what that minus pi over 2 does. All right, and so for the y's, we'll multiply all them by 2. Plot your points. But don't forget you're doing cosecant. So you got to have those asymptotes. So find that midline. All those points there become your asymptotes.
So are they always going to be on 0?
No. The next one won't be. If we don't have a vertical shift up or down, we don't have that K or that D value there at the end, then yeah, they're going to be on 0. But like you'll see the next example that has that K or D value that's a -1, so they're going to be on -1 instead. But that's why I don't worry about saying they're on the 0, okay? They're the middle points. You have your top points, you got your bottom points, they're going to do your parabolas, and your middle points are your asymptotes. Questions on that one?
What about all the identity values and all that?
Don't worry about those.
We're not doing those?
No.
What are they for?
It's just saying, it's what it is it's finding another way to graph. It's using the intervals. It's saying, let's find our first one.
Well, I need to know those for calculus or no?
Not if you graph it this way.
Alright, well, this
Okay. So what they're doing is they make you find your first point, they make you find your second point, and they use the fact that the middle point should be halfway between, and they make you find the halfways of all of them.
Yes, ma'am.
Okay? There's no reason to do it a different way. We're going to get the same thing at the end. Could you continue your pattern?
Yes.
All right, so let's do that. So I can see remember when I continue my pattern, I don't get real mathy at it. I just count how far apart we are. My asymptotes are what? 1, 2, 3, 4 boxes apart. So no, this is going to be a vertical asymptote. This is going to be a vertical asymptote. So is this one? And I know my top and bottom points are going to be 2 lines away from each of the asymptotes. And they alternate. So if I'm going to the left, at a bottom, a top. So the next one's going to be a bottom. Next one's a top. Next one's a bottom. Next one would be a top. If I go the other way, I know that next one going to the right then is going to have to be a top. Top points have parabolas going up. Bottom ones have them going down. Are we okay with expanding our graph? To be able to continue it, I guess I should say, not expanding it. Just follow your patterns. All right, then our last example here. It gave us 2 different ones. It's the same thing, okay? Remember, to do it the way we've been graphing, your bx minus h or bx minus c has to be all in one parenthesis. So we graph it using this form. If they give it to us in this form, we distribute it. All right, so secant is the reciprocal of thank you. And so I'm just writing down my cosine parent table. It starts at the top so I can have it to look at. Again, I'm not going to worry about all this stuff on the left. We've already talked about all of that. So looking at my equation, is there anything that's going to affect my x's?
Yeah.
Okay, what are we going to do?
Pi over 2. Oh, wait, no, pi.
Okay, so the pi, and the 2, correct? They both are inside with x. Which one do we do first?
Multiply.
PEMDAS says, say it again.
Divide.
Well, PEMDAS says we multiply or divide first, right? But X says we always do the opposite. So we're not really even going to multiply or divide first. We're going to add the pi, and then we'll divide by the 2. But remember, dividing by 2 is the same as multiply. Dang. So let me do my x plus pi before I start talking about a 2 and try to write it again. Dividing by 2 is the same as multiplying by 1/2. And what about my y's? Is there anything that's going to affect my y's?
Times the -1.
Well, I have a negative at the front here, so we're going to multiply by that -1. And then what about this?
Subtract 1.
Yeah, so we're multiply by -1, and then we will subtract 1 from that. Alright, so let's do our x's. My first x is 0 plus pi, which is times 1/2, which is alright, my second x is pi over 2 plus pi. Okay, gives us 3 pi over 2 times 1/2. Remember, multiply straight across, so we get 3 pi over 4. All right. My next x is pi, so pi plus pi is
2 pi.
times 1/2.
I wonder if that is the same. Wait, no. Wait. Yeah.
Yeah, it did. All right. Then I have 3 pi over 2 plus pi, just 5 pi over 2, times 1/2.
5 pi over 4.
Good. And then my last one is 2 pi plus pi, which is
3
times 1/2.
3 pi over 2.
All right, then for my y's, my first y was a 1 times -1 is -1 minus 1 is, okay. My second y was a 0 times -1, which is minus 1 is, my next y was a -1 times -1, which is, huh? Oh, y'all are jumping ahead of me? So 1 minus 1, which is 0. Now when I go to do the next one, I notice it's a 0, but we already did a 0, didn't we? And we got -1 for our answer. And then my last one was a 1, but I already did that at the very beginning there, and I got -2 as my answer. So let's plot those points. Remember, if you don't know where 3 pi over 4 is, that's okay. You know where pi is. You know where the pi over 2 was. You know 3 pi over 4 because it's listed in between them. Has to be graphed in between them. So it has to be that line that's right there between them. And it's at -1. And so even there, now you can see it's every line is getting a point. So 5 pi over 4 must be the next line over. And then we can see where the 3 pi over 2 is. Now remember, if this had been with cosine, we would just connect those points and we would be done. But it's secant, so we know we need those asymptotes. Do you see your middle points? All right, those 2 middle points are become your vertical asymptotes. Then the points that are on top, a little parabola is going up, and on bottom, are little parabolas going down.